Hi guys, this is just a short video to get you started with the Flexwork and hopefully clear up some of the confusing terms or stuff that we haven't completely covered in class. So let's get started. Okay, in determining if something's a geometric sequence like you're meant to do with the first 4 questions, all you need to do is divide each one by the one before it in turn and just make sure that they're giving you the same answer. So 216 divided by 36 is minus 6. Then minus 36 divided by 6 is minus 6. And then 6 divided by minus 1 is minus 6. Okay, so as it's going back each time when you divide it by minus 6, you times by minus 6 to bring it forward. Therefore, yes, it is a geometric sequence. And it has a ratio of minus 6. And sorry, that should help you with the first 6 questions. Okay, given the explicit formula for a geometric sequence, find the first 5 terms and the 8th term. Okay, to find the terms in a geometric sequence, what you do is replace the n with 1, and then the n with 2 to find the second term, and with 3 to find the third term, and so on. So the first one is 3 to the 1 minus 1, with replacing n with 1, which is 3 to the 0, which is just 1. Then the second term, or term 2, is 3 to the 2, because n is suddenly 2, minus 1, which is 3 to the 1, or 3. Then 3 to the 2 is 9. 3 to the 3 is 27. 3 to the 4 is 81, giving us term 1, 2, 3, 4, and 5. And then to work out term 7, we just go A7 equals 3, 7 to the 1. So to work out term 8, 8 to the 1, which is A8. And then that is 3 to the 7, which equals 2,187. Okay, so just do the same thing for the next 3 questions and it all should work. Okay, this is something that we haven't covered in class, but I would like you to have a go at in the Flexwork. Okay, here we're using the recursive formula, which is a little bit new, for a geometric sequence to find the ratio, to find the common ratio and the first 5 terms and the explicit formula. What they have here is the recursive formula. Okay, and it's a recursive formula because you use n minus 1, the earlier number in the sequence, to find n, the later number in the sequence. Okay, and I'll show you how you do this with the first 2 and get the things that we're asked for, and then hopefully you can have a crack at it yourself with the later 2. Okay, so here's how we go. These generally will give you 1 term in the sequence. Here we have A1. So start off with A1, or your first term, is 2. And then 2 goes into the yellow box. So your next term, or AN, equals 2, our first term, times 2. So 4. Now we've got 4 as our last term in the sequence, and we're trying to find the next one. So our a to the subscript n minus 1 times 2 equals 8. Then 16 and they're the first 4 terms in the sequence. Oh, it asks for 5, so 32 as well. Okay. Find the common ratio. That is always this orange number, the 2, or the thing you're timesing the previous number by. So here we can just go R equals 2, and then we can put these into our regular formula. So Tn, the term in the sequence, equals 2, our first number, times 2, our second number to the n minus 1. Okay, and we're done. Here we have our second one. So our first term in the sequence is minus 3, because we're given that there. Then we take the last term in the sequence we have and times it by minus 3 to get our new term. So we go minus 3 times minus 3, which is 9, 27, 81, 243. Okay, here you can see R, or the number that we're timesing by our common ratio, is minus 3. And thus we use the formula Tn equals minus 3 times minus 3 to the n minus 1. Okay, give the other 2 a go. If you get them wrong, we'll go through it again and again in class, or come and see me and I'll give you a hand. Okay, but it's worth having a think and getting that recursive formula down, because it is very useful for programming things like computers and calculators that use the previous number in the sequence to get the new one. Okay, for our next page, we're asked to evaluate the series for each sequence, which is just to add all the numbers. Okay, and for that you can use the formula or your calculator. I'm just going to use my calculator to speed it up a bit because there's not that many. 2 plus 12 plus 72 plus 432 equals 518. Okay. Just for you guys to show off the formula and how it relates to that. Okay. What you could have also done. Actually, no, I'll skip that. Okay, finally, here's a little bit of sigma notation. Okay. This sign here is capital sigma. And he means to add everything up. Okay. Now, writing down all the numbers in a sequence and a plus between them to say you need to add everything up here would be hard. Okay. So sigma is a shortcut for that. It just means everything in the sequence that follows, you need to add up. Okay. And the number here in this capital, underneath the capital sigma, tells you where to start adding. So we start adding at the first term. And the number up here tells you when to stop. So the bottom is your start number. And the top is your stop number. Okay? And you're adding up this rule or this sequence. Okay? So let's get started. We use our K notation to find the first number in the sequence. So we're looking for A to chuck into our formula, and it's 4 to the 1 take 1, which is 4 to the 0, or 1. You've got your common ratio, which is 4, because with this power thing, each time the power goes up by 1, you times it by 4 again, giving you a common ratio of 4. Then you'll also need n, or the number of terms in the sequence, which is 7. There are 7 terms in the sequence. 1, 2, 3, 4, 5, 6, 7. Okay? So now I'm just going to write it all out in the formula. Sn, our sum of our sequence, equals A outside of n minus 1. Sorry, A outside of R to the n minus 1 over R minus 1. Okay, substitute in the numbers. 1 outside of 4 to the 7 minus 1 over 4 take 1. Okay. And I'll just put that into my calculator. 4 to the power of 7 is 1638 4. Minus 1 is 1638 3, all divided by 3, equals 5,461. Okay, now that's a process you should be getting familiar with. The sigma notation should be new, but the process shouldn't be. Okay, so the main thing that I want you to take away from this is just that the sigma sign, that capital weird Greek letter thing, means to add up everything that comes next. Start at the first term, stop at the 7th. Okay, and the formula just supports that happening. Okay, if you've got any questions, again, come and see me. But best of luck in the flex work.